This video will cover Lesson 9 in Module 3 of Eureka Math Level 7. We're going to start with just some diagrams and some different types of angles and the equations that would be written in order to find these specific angles. Okay. We'll start here with the angles themselves. Okay. There are 4 different angles. Four different sets of angles, I should say. Okay. And so, in looking at these, and with our paper, I first want to figure out which are supplementary. Where would I find a pair of supplementary angles? Well, supplementary angles, okay, remember, are angles, 2 angles that add up to 180 degrees. So if I'm looking at my sets of angles, the 2, okay, this would give me 180 degrees, but there's more than 2 angles. This is 2 angles, but they don't add up to 180. That box tells me 90. Right here, I've got 3 angles. However, if you look, okay, I've got 2 different ways that I can come up with how to find the supplementary angles. I could say that these 2 angles right here, or these 2 angles right here. So this is going to give us our supplementary angles. Okay. So when we're looking at that, we're going to look at, okay, which of these would give me a 180 degree angle, or which one of these would give me the equation that represents that. Okay, so if I'm looking at which ones equal 180, well, that automatically eliminates these 2. So we're left with these 2 angles right here. Okay, so if I'm looking at this, I have these 2 angles right here, or these 2. Well, if I add these 2 angles together, they equal 180. Well, and then if I add these 2, I have 5x plus 7x plus 96 equals 180. Well, this doesn't have a 96 anywhere. This one does. Okay, so figure 1 would match up with the equation 12x plus 96. The reason why is because when I add these all together, 5x and 7x equals 12x. Okay, and then we have the 96 left over, and together they equal 180. Okay, supplementary are 2 angles that equal 180. Okay, we found these 2 equal 180. Okay. Next, we're going to look at a complementary angle, complementary angles, and complementary angles add up to 90 degrees. Okay. Well, if I'm looking at these 3, again, we have a straight line here. That one's out. So it's down to these 2. If we remember, a right angle has that box that tells us it's a 90 degree angle, and figure 4 has that box. And we have 2 angles. So the 2 angles that add up to 90. So again, if we look at our cards, our equation cards, that's not 90, that's not 90. So that leaves us with 3x plus 9 equals 90. How does that work? Well, again, I'm going to combine these 2. 3x minus 7 plus 16. Well, I'm going to combine my like terms of the negative 7 and the 16 to get that 9. So my equation that represents this would be 3x plus 9 equals 90. Going to flip to the other side of the page here, and we're going to look at angles on a line. Okay, well, angles on a line, well, they make a straight line. There's only one of these 2 angles that make a straight line. Figure 3. Angles on a line add up to 180. So process of elimination is just simply this equation right here, because it's the only one of those two that equals 180. The reason that it's 2x plus 30 is, well, 7/4 x plus 1/4 x. Well, that gives me 8/4 x, which is 2x. And then I have 67 minus 50 makes 17, plus 13 makes 30. That leaves the last one to be adjacent angles. Adjacent angles are just angles that are side by side. They share a point, an array, but they have no specific amount. It's telling me right here that the angle is 130 degrees altogether on this arc. Okay, so by combining the two angles, I get x plus 4x minus 10, and x plus 4x is 5x. So 5x minus 10 equals the whole thing, which is 130. We talked about those other angles, okay? Now let's talk about some new angles here. We have vertical angles. Okay? Vertical angles, the definition here on that, zoom in here so get a little closer. Okay? We have intersecting lines of EC and DB at this point. Okay? Vertical angles, okay? Angles are angles that share a vertex but no rays. Okay? These angles are congruent. Okay? These angles are congruent. Okay? So in this case, we're going to use this information. Angles that share a vertex but no rays. Okay? Here's the vertex. That's the center. That's what they are sharing. Okay. If I look at angle EAD, remember we start at E, go to A, come back out to D. It shares a vertex with DAC, EAB, and CAB. However, the only angle that doesn't share a side with EAD is CAB. If you notice, okay, so if I write this out, if I say angle DAE and angle CAB, the only thing they share in common is that middle point. That's the vertex. That is how you know that you have vertical angles. Okay. In this situation at least, okay? Because if I would say EAD and DAC, well, they would share that D as well as the A. If I said EAB, they would share the E as well as the A. Okay? So vertical angles are going to share that middle point, okay? And I like to say they open up away from each other. Okay? So they are congruent. Now, that means 5x and 35 are congruent, are the same. That would also tell me that these two angles are the same. So vertical just doesn't mean on top. It could mean on top. It could mean side. They share a point with no sides. So DAC and EAB are also vertical angles. Again, they share this point, but the sides are not in both angles. Okay? So for question 2A, it's asking us to solve for x. Well, if I know that these two angles are congruent, that means they are the same. Congruent means the same. So I know that angle DAE is equal to angle CAB. And again, we're naming these starting outside to the inside, back to the outside. Okay, because if I said, hey, where is angle DAE? You would find D, go to A, and go to E. And then everything in between or the angle part that's in between those two lines is what we're referring to. Okay. So if I know that angle DAE and angle CAB are equal to each other, I know that DAE is 5x. I know that CAB is 35, so I know these two things are equal to each other. Now we're back looking at those, at these measurements, okay? We're looking to find these measurements of these angles. We're looking at our equations. Okay, so if I know that 5x equals 35, we're back at that one-step equation that we've talked about previously. And this means 5 times x. Okay? There is a multiplication symbol in between the coefficient and the number, and the variable. Okay? 5x means 5 times x. There's a multiplication sign in between here. The inverse, or the opposite of multiplying, is dividing. Okay, I want to turn x into just x. I want to get x equals. Well, x is just 1x. So how do I go from 5x to 1x? Well, how do I turn 5 into 1? I divide it by 5. And what you do on one side, in order to keep the equation balanced, you have to do to the other side. So 5x divided by 5 is 1x. And 35 divided by 5 is 7. Okay, so x equals 7. Part B says check the solution. Again, that's when we're just going to use our equation. We're going to use our solution. And we're going to replace x with our solution to determine if we have the correct answer. 5 times 7 is 35. And this makes a true statement. So we do, in fact, have the correct solution. D wants us to talk about DAC, DAE, and BAE. Okay? Well, DAC, well, we know that's 7x plus 96. Okay? That's angle DAC. And we know that x is 7, so we're going to replace x with 7. Okay. And 7 times 7 is 49, plus 96 gives an answer of 145. So angle DAC is 145 degrees. DAE is 5x. And we're going to replace that x with our solution, which gives us 35 degrees. Well, if we know that DAC is 145, okay, we can also say that BAE is 145 as well, because DAC and BAE are vertical angles. They share that middle point, okay, and again, they open away from each other. They don't share any sides. Okay, angle BAE, okay, is equal to angle DAC because they are congruent vertical angles, and a DAC is 145 degrees, so is angle BAE. I got a little bit ahead of myself here, I think, because in part D it says, what do you notice? Well, we could say that we notice that DAC and angle BAE are vertical angles. Okay. We could say that EAD and DAC are a linear pair. We could say that DAC and CAB are a linear pair. Okay, both of those would work in our situation. So the key point in this part of our thing is remember this definition. Vertical angles. Okay. Vertical angles are angles that share a vertex, that's the middle point, but no rays. So they don't share any sides. And they are equal to each other. If you're ever given two angles and it says what is x or what is the measurement, you're just quite literally going to put this equals this. Okay? Next we have angles on a point. Angles on a point, okay, here's an example right here. All these angles, okay, well I have this angle, if I started at C and went all the way around, that would give me all around in a complete circle. Okay, and circles are 360 degrees, so angles on a point, okay, are angles that add up to 300, so they equal 360 degrees, okay, but they're angles that all share a vertex and combine to make 360 degrees. Okay? So they're 360 degrees, they all share a vertex, okay, and there's usually more than two. So when we're talking angles on a point, they're 360 degrees, and they share a vertex. So if we looked at that diagram in question 2, so if we go back here, these are also would be considered angles on a point, all of them together. And if we combined all of their measurements, we would determine that they add up to 360 degrees. Okay, so specifically, all of them are angles on a point, but those sets are vertical angles. So let's use our knowledge about angles on a point that we just talked about. Okay. Well, describe the relevant angle relationship. Okay. We would say they're angles on a point because these angles, okay, I could start here and I could make a whole entire circle, right? Okay. Get that mark off there though. So I'm going to start here and I'm going to make a whole complete circle. That's how you know they're angles at a point. Part B wants us to write the equation. Well, if they're angles at a point, I'm going to add all of these up. So I'm going to have 3/4 x plus 9 plus 3/4 x plus 9. There's that one. Plus 1/2 x minus 17. I'm adding all of these together. Okay. And as a whole, since they're angles at a point add up to 360 degrees. Now it wants us to solve this. Well, we're going to combine all of our like terms. So we're going to have x, x, and x. And we're going to have 9, 9, and negative 17. Well, we can't add all these x's together because I don't have like terms. But we could say that 1/2 is the same thing as 2/4. Okay, so this is really 2/4 x. Okay, so now I can add all of my terms. I could take 3/4 plus 3/4 plus 2/4. Well, 3 plus 3 is 6. And 2 is 8. So I would have 8/4 x plus 9 plus 9 plus negative 17. 9 plus 9 is 18. 18 plus negative 17 is 1. And still that equals 360 degrees. Okay. 8/4 x. That can be rewritten because 8 divided by 4 is 2. 2x plus 1 equals 360. Now we're back to figuring out these equations. Well, the first thing we're going to do, remember, number 1, get rid of the number without a variable. So since this says plus 1, I'm going to say minus 1 on both sides. 1 minus 1 is 0. 0 plus 2x is just 2x. And 360 minus 1 is 359. Well, we still don't have x by itself, so in order to get 2x to turn into 1x, we have to divide by 2. Because 2 divided by 2 gives me 1x, which is going to be x. And we're going to divide both sides by 2 in order to keep the equation balanced and equal. When I divide both sides by 2, I do get an answer that's going to end up being a decimal or a fraction. So I'm going to end up with 179.5, okay, or 179 1/2. In your two-step, okay, write the equation, okay, take all the angles and put plus in between them, because that is how we're going to collectively get that entire angle. And we know because they're angles at a point, they add up to 360 degrees. Combine your like terms. Okay. So if we're going to go from here to here, combine like terms. To go from here to here, we just simplified the fraction. Right here we eliminated, wow, I cannot spell. Okay. Eliminate the constant, okay, which is what happened. And then we are going to eliminate the coefficient. Coefficient is that number in front of the variable that is being multiplied to the variable. Okay. Continuing it, this wants us to check our equation. Okay. Well, again, that's as simple as just saying, rewrite that equation. Well, I know I had 2x plus 1 equals 360. If I'm going to replace x with 179.5, well, 2x, not 2x, we're replacing x. 2 times 179.5 plus 1 plus not 3. I apologize for all the mistakes today. My mind is working faster than I can think. So 2 times 179.5 is going to be 359. And when I add 359 and 1, that gives me 360 equals 360. And that is, in fact, true. So we have a correct statement here. Okay. Determine the measurements for angles ABD, BDC, and ADC. Well, the good news is that if we look at these two of these, so ADB, let's start with ADB. Well, ADB, A to D to B, is 3/4 x plus 9. 3/4 x plus 9. We're going to replace x with 179.5. And so when we do that, again, calculators are allowable here. So feel free if you need to use that. Okay, that's fine. So when we take 3/4 times 179.5, we get 134.625 plus 9, which is 143.625. That is angle ADB. If we look, we notice that we have another angle that is exactly the same, BDC, which is the next angle it wants us to find. Well, angle BDC is 3/4 x plus 9, and we just figured that out. We figured out angle ADB, which is the same as BDC, so 143.625. Angle ADC is the last one we're going to find, and that has a measurement of 1/2 x minus 17. So I have 1/2 x minus 17. I'm going to replace 1/2 with 179.5. And then I'm going to multiply times 1/2, which is 89.75 minus 17. So I subtract 17. I have 72.75. That is the measure of angle ADC. And if I add all three of these together, that gives me a measurement of 360. Okay. Don't forget your degrees. I keep forgetting that. Oops. Okay. There are your measures. Okay. Take what the angle is, replace x, and just follow the order of operations. Okay. Number 5. Okay. It has all of these lines intersecting at point A, and it wants us to find the measures of BAC, so this angle right here. It wants us to find the measures of BAF, so this measurement, and CAD, so this one. So these three measurements. Oh, and, sorry, I missed one, DAE. So everything except for the one that we already know is 32 degrees. Okay. We could say lots of different things here. We could say angles at a point. Okay. For all. We could say that angle BAF and angle FAE are supplementary, which means I could take 180 minus 32, which gives me 148 here for this angle. So if we, okay, so we could do that and find that one. Okay, but altogether they are angles at a point. Okay, I would start with figuring this one out though, because that's going to help you out. We don't know what that is. We also don't know what this one. You got to figure out what this angle is. Okay, but really, in order to do that, we got to find some different measurements here, some different things. There are all kinds of angles that we need to come up with. Okay, in order to find CAD, we need to actually find X first. Okay, because we need to figure out X because we have these three lines right here that are angles on a point. Okay, so we would say in order to find X, I have BAC and FAE. These angles are vertical angles. They share this point and they open away from each other. They don't share any sides. So I could say FAE and angle BAC are vertical angles. And then I could say that I have BAC, CAD, and DAE. So BAC, CAD, and DAE. Those are angles on a line. BAC, angle CAD, and angle DAE are angles on a line. There's a lot to kind of dig through there with all of those different kinds of angles. Okay. So even though this says the angle relationship and solve for x, okay, well, that would be quite simply The vertical angles. I know that we said angle EAF is equal to, FAE, EAF are the same. Angle BAC. Okay. If I go back and look again, I know I'm flipping back and forth an awful lot, I'm sorry. The EAF is 32, and B is 8x plus 27. So I have 32 equals 8x plus 27. Okay, we have our two-step equation that we need to solve here. So our first process in that is going to be to get rid of the constant. So plus 27 means I have to do minus 27 for the inverse, which leaves me with 5 equals 8x. Now, since 8 times x, the inverse of multiplying is to divide, and I need to divide to get 1x. Okay, so 1x, or just x. Okay, and 5 divided by 8 is 0.625. So now that we know what x is, we can use that to kind of solve for the rest of these angles. Okay. Now that we have the answer for x, we can use that in our equation. Okay. So 32 equals 8x plus 27, with our answer of x being 0.625. Replace x with 0.625. Multiply, that gives me 5 plus 27. 32 equals 32. Well, now we know what the measure of BAC is, because it is the equivalent of EAF, because it is a vertical angle. But we also know that it's 8x plus 27. And we just did that up here to figure out that we have a measurement of 32 degrees. Angle DAE, if we look back, angle DAE has a measurement of 68x. So we're going to replace x with 0.625 and multiply. So if we multiply 68 times 0.625, we get an answer of 42.5. So DAE is 42.5. The next one we want is BAF. BAF. And we've already figured that out because we did 180 minus 42 minus 32, 32, which gives us 148 because of the supplementary angles. And if we know the rest of those angles, we can figure out CAD, because angle CAD is equivalent to 360 minus everything else. So minus 32, minus 32, minus that 42.5, and then minus 148. Okay. So, or you could think of it like this, with plus. I think this one is a better one. Add up all the other ones and subtract that from 360. So let's do that. Let's add all these up, subtract that from 360. So when we do the math there with that, okay, we get an answer of 254.5. So 360 minus 254.5. Then when we subtract that from 160, we get 105.5 degrees for angle CAD.